So in today's class, guys, we are going to do a very important work, and that work is going to be training our own YOLO model with our own dataset. So own dataset means going forward from today onwards, you will be able to take any kind of a data, and you will be able to train with those dataset. You will be able to create your own custom model. Plus, I'm going to even teach you that how you can create your own APIs. APIs means so you can try to call your model anytime you want, and even you will be able to host your model on any cloud platform. So I'll try to host that model on a render.com. You can try to host it on a AWS, Azure, GCP, or any given cloud platform, and then anytime, anywhere you want, you will be able to, or anyone will be able to call your models, and they will be able to test it. So this is something that we are going to do it in today's class. Yeah. So are we ready, guys? Everyone? Yes, so please confirm me yes, guys, in a chat, and then we are going to start training our own YOLO model. In the last class, I believe I talked about inferencing, so how we can do inferencing with respect to a pre-trained model. But yeah, that was a pre-trained model, by the way. And in today's class, so we are going to see how to do it with respect to our own models. Okay, so let's get started, and process is a little bit complex in a beginning, and you will feel like it's complex, but yeah, I'll try to move in a step by step manner. So we have to do a lot of not a lot of configuration, but yeah, a little bit of configuration we'll have to do in our system so that we can train our own YOLO model. We can try to even label our own image data set. Yes. So you will train the model for a image segmentation detection for detection. So if you can do it for detection, you can do it for segmentation as well. So it's like a just one step ahead. Okay, so guys, first of all, to train our model, we need a data set. That's a very first part. Second part is that we have to basically label our images, and in case of classification, we have seen that it's very easy. So we can try to create a folder structure, and then we can try to name a folder as per the name of the classes XYG, and then respective images we can try to keep inside that folder, and then we can try to train our classification model. And that is something that we have already seen, right? So those steps and custom classification model training, we have already done that. But what about object detection? Because in case of object detection, so it will try to draw a boundary boxes, right? It will try to draw the coordinates. It will try to draw the boundary boxes as an output. So how I will be able to prepare my data set for training a model with respect to these object detection means whenever I'm going to do a inferencing, it should be able to draw the boundary boxes the way we have experimented in a last week itself. And this is something that we are going to see, that we are going to build basically in today's class. So the very first requirement, let me share my screen now. So I believe my screen is visible. The very first requirement that we have is to acquire a data set. So I can try to go to Google, and I can even take my own custom data if that data set is available in my system, but it's completely fine. I'm going to take some of the data set for a healthcare, let's suppose. So maybe I can go to Hugging Face, and I can look for a data set. Even I can go to a Kaggle, and I can try to look for the data set. So maybe I can look for a image data set from here, and let's see if we are able to find out some medical data set. Or so here you will be able to find out a tons of a data set. This is one of the place you can try to even look into a Google data set, or you can go to a Kaggle data sets, and even from here, so you can try to browse a data set that you are looking for. And like I said, so if you would like to take some data set which is available in your system, it's completely fine. There is no issue with that. So here maybe healthcare data set. Brain tumor data set, but it's a CSV data that we have. We can try to apply some filter over here. So CSV, JSON, BigQuery, GraphQL, this. No, I'm not looking for these data sets. So MRI, CSV again, CT medical data set. Okay, fine. So likewise, you will be able to find out not just one or two, but you will be able to find out a multiple data set. So this is basically a CT scan medical image data set for cancer, you can see. So CT image for a cancer imaging archive with the contrast and a patient age. So this is the data set which is required. I just need a image, that's it. Apart from images, so nothing else is required, so that I will be able to teach you that, okay, fine. So how you will be able to identify or how you will be able to train it. So maybe I can go ahead and I can try to download this particular data set. So here is a link, guys, and Durgesh is saying Roboflow. I'll come to that point. So I'm going to use a label IMG. You can use Roboflow as well. But yeah, in a class, I will be using a local one, which is like a label IMG. So just sign up, guys, and then I will be able to download this dataset, 262 MB. So I have already pinged you the link in a chat. So please download this dataset, by the way. And yeah, Durgesh is suggesting even a Roboflow. So Roboflow is again another platform. So where you can go and you can try to download a computer vision based data set. So this is also a place. There are a lot of places nowadays. So one is a Hugging Face, one is a Kaggle, one is a Roboflow, one is a UCI repository, one is a Google data set. So there are not just one or two, there are tons of places from where you will be able to acquire whatever kind of a data set that you want. Because if we are trying to train maybe for medical images, so obviously unless and until someone is not giving me a data set, it will not be available to me. So you have to go to some of the platform. Otherwise, if you have some access from a hospital data set, you can go ahead and you can try to take it. So anything is completely fine for us. Yeah, so Roboflow is one of the places, Kaggle is one of the places, Hugging Face is one of the places. I'm going to download a dataset from a Kaggle. You can pick and choose any of these dataset. So fine, dataset I'm able to download. So let's try to unarchive this dataset, unzip this dataset, and let's see. So what is there inside this particular dataset? So archive, and then here, so TIFF images, I'm able to find out. And let's see how this image, this is a TIF format. So if it can give me in a PNG or JPG format, so I think that will be better. No, it's not a data set that we should take, because I have to convert that into a PNG or JPG. Oh. So not this one. It's a different format. It's a TIFF format basically. Maybe X-ray ID. Let me try some different data set, because that data set was having a TIF. It's not like we can't do it, but yeah. So we can like take even that particular data set. But the problem is I'll have to do a conversion of this data set. So let me download this data set, download zip to the computer. So fine, select format. So JSON, Pascal, CSV, let's say YOLO 8. I accept and continue. Set up your account. This is something that I don't want. No. Let me search for some different data set, guys. X-ray. So maybe I can search with that. So chest X-ray image pneumonia. And it's a 2 GB of data set, chest X-ray, 1 GB of data set, corona hack, chest X-ray, 1 GB of data set. I need a couple of files. So maybe I can try to choose a corona hack. Let's see. So here, no, this is basically a CSV file. I don't want that. CSV and then 2 GB. This one is file others, chest X-ray. It looks like it's having a image data set. Let me check what is the extension of the data set. Joey has pinged me one of the data. Actually, I have a data set in my local system, but again, that data set is like a in a TV, so I don't want to like ask you to use that data set. While I was preparing this entire use cases, so I already have that data set. Yeah, even I can take this one. That's completely fine. But I would like to take some sort of a healthcare data set. So I can take even this data set because the images are pretty much clear, and then I can label all of these like objects over here. But I'm looking for some healthcare data set, guys, not this one, because we have a healthcare project, so we'll have to complete that. Healthcare, X-ray image. Let's find something good on a Kaggle itself. 4 GB chest X-ray. Bone fracture multi-region X-ray dataset. So maybe we can label this one bone shadow suppression. We have a brain tumor dataset over here. Chest X-ray 2 GB chest X-ray dataset for tuberculosis segmentation. COVID dataset NH chest X-ray. Okay, 45 GB. It's like too much. 10 GB again, too much. Random sample. This is a CSV one. And why they are not giving a filter over here? License usability. They are just giving filter for this file system. Hmm. Just a minute. Let me find something good, something small. Maybe I can take a help from Yuri. Web search. Give me a data set. Okay, chest X-ray, brain tumor. Let's see if we have a data set over here. Data set file. It's a 1 GB file. So yeah, it's a small one. has started downloading the data. I can take any kind of images which is even available in my system. So I will be able to build a model with respect to any kind of object detection. But as we have some healthcare scenario in our project, so keeping that in mind, I'm like trying to acquire some healthcare data set. And in my system, I already have a lot of data, these kind of a data, but I don't want to take it. So I've already trained my model with this. So taking a lot of time, 6 minute brain tumor. Let me see if we can get this data. GitHub brain tumor YAML. No, I don't want that. Brain tumor. Okay, so negative. Data training, fine. Planning in healthcare application. Where I can get this data. Durgesh is saying this is JPG. Okay, let me check. Chest X-ray 1.24 GB, normal and pneumonia. So it's for classification we can use. So we have to do a boundary boxes, right? So here you will be able to find out that there are two classes. One is a normal, one is a pneumonia. And basically it's based on the overall data set. I assume that these people are trying, these people have uploaded. So no, I have to do a boundary boxes basically. This kind of a boundary boxes I have to draw on my own. So I'm downloading it. I'm downloading one of the data set. So I'm just looking for some different alternative. Okay, so I'm able to get one small data set, guys, from Ultra Analytics itself. Let me ping you that link for this small data set. I think it will be like feasible for all of us to do the training in a class itself. So please download this data set. It's an MB. So it's a 4 MB of a file that you will be able to find out. And there are like so much of files which is available inside this data set. It's a very small one. Yeah. And it's for a brain tumor, by the way. So just download this dataset, guys. It's a very small dataset. So I believe for a live classes, because I have a dataset and even you will be able to find out so many dataset. but all these data sets are available in 10 GB, 45 GB. I just don't want to use it. I just wanted to use something like this, right? So where I will be able to label this data and maybe colorful, maybe this kind of images, that's completely fine. So this is the brain tumor data. You all will be able to download it, and inside this data, so we have basically images which is available to us, and along with images, you will be able to find out basically labels. So this kind of a labels means this kind of a numbers you all will be able to find out. But we are not going to consider a label. We are going to create our own label on your own. But before that, so I'm even going to give you the explanation about the same thing, exact same thing. So see guys, what we are going to do is that just look into these images from Ultra Analytics, right? So just for the sample one. So here we have multiple images, and even the file that we have downloaded, inside this file, you will be able to find out multiple images. Now what we have to build, by the way, okay, so where is my file? D drive, this one, and brain tumor. Yeah. So when you are going to download this dataset, brain tumor dataset, and when you are going to unzip it, you will be able to find out two kind of a dataset. One is a train and one is a validation. So again, this is what we do even in case of machine learning or even in case of any kind of a training. So we'll be having two kind of a data set, train and validation, doesn't matter at all. So we can try to consider just a training data set for now. And inside training data set, you will be able to find out a lot of images, not just one or two images, but you will be able to find out a lot of images over here. Now, parallel to this, you will be able to find out something called as labels. Yeah. So you will be able to find out something called labels. Now, what is this label, by the way? So inside these labels, you will be able to find out something like this kind of a numbers, right? This kind of a numbers inside all of this label.txt, you will be able to find out these kind of a label across all the data set, Now, so when you are going to check that what this brain tumor is all about, so come to data.yaml, and maybe you can try to open up into some of the text editor, and inside this YAML file, you will be able to find out two classes. One is a negative class and one is a positive class. Means in one, some of the images we have a brain tumor detected, and in some of the images we don't have a brain tumor detected. So negative means no brain tumor and positive means we have a brain tumor, by the way, as simple as that, right? Now, so here someone has created this negative, someone has created this positive class, by the way. How they have created? So they have created it with the help of labeling the data. Labeling the data means they have created a bounding boxes. For example, so if I'm going to consider this data set, and let's suppose if I am trying to label this particular data set, so I have to create a boundary boxes. I have to create a boundary boxes just like this, right? So where it will be having a coordinates. So I have to create a boundary boxes just like this at the time of labeling of the data set, and then the coordinate, the fourth coordinate that you are able to see. So basically it's representing all of these points inside this images, all this axis it is trying to represent, and then it is trying to represent 1 or 0, means it is trying to represent basically a classes. So class 1, class 0, class 1, class 0. So likewise, if we have n number of classes, so I can try to label my images with respect to that many number of the classes. Now, the problem is that someone has already done those labelings. But let's suppose if I have just this images, I don't have any kind of a label, and I don't want to label it as 1, 0. Maybe I would like to label it as a good or bad, right? Not 1, 0, not negative, positive, maybe good or bad, or tumor, no tumor, tumor, no tumor. So maybe this is the kind of a label that I would like to give. So how I will be able to create my own custom labels? Because at the end of the day, so at a source, right? At a source, we will be having just this images. Let's suppose you have asked a doctor, or maybe you have asked a hospital to provide images, and they have just provided you this particular images. And then you know that okay, so inside this image, there is a tumor, there is no tumor, because this is how doctor check, right? So manually, they will try to check that, okay, fine. So in this region, so maybe it is representing a tumor. Maybe in this region, it is not representing a tumor. But I just wanted to do these things, do this entire identification with my machine. Now to do this entire identification with respect to my machine, I have to first of all label, and then I have to send those data, means this image and a label, to a model, so that model will be able to train itself. Once it will be able to train itself, then only it will be able to give me a prediction with my own custom labels, good or bad, or maybe tumor or no tumor. Getting my point, everyone? And are you able to download the dataset? So inside this dataset, the dataset that you have downloaded, we have a label available, but I'm not going to use that particular label. I'm going to create my own labels, as simple as that. Fine, guys. Yeah, so are we able to acquire a data set? Part number 1, everyone? Are we able to download the data set? So the GIF link which I have given to you. So here you will be able to find out this data set. It's a very small one, 4.5 MB of a data. So it is not going to take much of time. And then in a later stage, you can go ahead and you can download even a GBs of a data. There is no issue at all. Yeah, there is no issue at all. Fine. Now, inside this data set, you will be able to find out that in some of the images, there is no tumor. And in some of the other images, let me show you those tumor images basically. So in some of the images, you will be able to find out a patch. Patch means a tumor. You will be able to find out. For example, this image, right? So here we are able to find out a patch. It simply means that the image that we are looking at, so this person is having a tumor, and so wherever we are not able to find out this kind of a patches, it simply means that that person is not having a tumor, right? So as a human, I'm able to identify it. Maybe as a doctor, I'm able to identify it. But how my machine will be able to identify, that is something that we all are supposed to build. Simple, right? Simple. Now, someone has already provided you a labels. I'm not interested in that, right? I'm not interested in that. I'm going to create a similar kind of a label on my own. How? I'm going to show you. Now, to create a label, there are different kind of tools which is available in a market. There is something called as Roboflow. There are a lot of automation tools you will be able to find out. Means you are going to just label a couple of images, and then rest of the images, it is going to label it automatically. And in my class, in today's class, we are going to use a tool called as Label IMG. Label IMG is again one of the tool that we have been using. I think even 8 years back, I have been using like a label IMGs, and we used to label thousands and thousands of images in a day. And this job we used to assign at that point of a time. So we used to assign this particular job to all the interns that, okay, so here are 50,000 images, and this is something that you have to label. These are the classes, XYZ classes. So just keep on labeling it, and it's a manual approach. And whatever label that you are able to see, or whatever data that you are able to download where labels are available, right? Labels are available. So someone has actually labeled it the way we are going to label it in my today's class. Yeah. So first of all, what you have to do is, so you have to open up a VS Code, right? Open up a VS Code. And then we are going to set the environment for the project. So file, open folder, any of the folder you can try to open up. And I'm going to name it as a YOLO custom training. Yeah. So I'm going to name my a folder as a YOLO custom training. And this is the complete empty folder. I'm going to start from complete scratch with no prerequisite. So here, what I will do is I'll try to create first of all my virtual environment so that I can keep everything independent of each and everything. So here I'm going to create an environment. So conda create -n YOLO env YOLO environment Python is equals to 3.10 and all yes. What happened? So conda create -n YOLO environment. So this is the new environment I'm trying to create, guys. So please try to create a new environment. Data annotator. Yes, that's true. So just create a new environment, guys, all of you, and activate this new environment. So the way I have done that, so I have activated my new environment, as you can see. So CLS. Now what we have to do. So first of all, we are able to acquire a data. So that's completely fine. Now we have to basically label those data set, and we have to keep those labeled data set in a particular structure, because training is not a big deal. You will be able to see that within 5 lines of a code, I will be able to do a training, right? Just within 4 or 5 lines of a code, not more than that. But you have to maintain the structure of the file while you are trying to train it. That's very much important. So what is the structure that we all are going to create? Let's do it. Yeah. So first of all, what you have to do is, so you have to create a proper like a structure for your data set. So here, create a folder called as dataset. Yep. Inside your main folder, create a folder called as dataset. Now inside this folder, right? Inside this folder, create another folder called as images images. Yeah. Inside dataset folder. Now again, inside a dataset folder, create another folder called as labels, labels. Yes. So labels, create a folder. So inside a main folder, there will be a dataset folder, inside that images folder, and then there will be a label folder. Now inside images folder, right? Inside images folder, you have to create again another folder called as train, train, train. Now inside images folder again, select images folder, click on that, and then you have to create a folder called as validation. Now, so dataset, image folder, inside that train and validation. Same thing you have to do for our labels as well. So under this train, train, and then under this again a validation. Yeah. So here, this is the folder structure I have to maintain. Dataset, inside dataset images, simple, right? Dataset, there will be images and there will be labels. Inside images, train and validation. Inside labels, train and validation. Is it making sense, guys? All of us are able to do it? Yes, everyone? Is it fine? Are we able to do it, guys? Yeah, it's very simple. Okay, so this is the folder structure. First of all, you have to maintain part number 1. Now, so once we are able to create these folder structure and we are able to create a fresh environment, and again, this is just a one-time job. The way you are going to train or the way you are going to annotate for one task, you will end up annotating for n number of tasks as well. So it's not going to be different. It's going to be exactly same. Exact same means exactly same. You don't have to do anything extra. If you are going to do a training for one of the task or one of the application or maybe other thousands of application, every time you have to do the exact same thing. This is the well-defined standard approach. So it's kind of a monotonous task. If you are able to do a training today, maybe after 1 year, you will be able to do a training again without any kind of a modification, without any kind of a change. This is how training actually works. So it's not a big deal. For the first time, it looks a little bit overwhelming, but yeah, from the second time onwards, not at all. So this is the folder structure we are supposed to maintain. Now, once we are able to maintain this folder structure, once we are able to maintain this entire folder structure, then what we have to do is, so then we have to place a image inside the image folder, and then we have to place a label inside a label folder. As simple as that. So label inside the label folder and image inside the image folder. Now, the data that I have downloaded so far, so this data that I have downloaded so far, so it is having a images as well as it is having a labels. I'm not concerned about image labels at all. I'm not going to consider these labels. I'm going to create my own label. So complete own label I'm going to create. What I'm going to do is I'm just going to use a raw images, just a raw images, so that I will be able to label my own images with a tumor and no tumor. They have given positive, negative. I'm not even going to use their labels. They have given 0, 1. I'm just going to create my own. Maybe you can just name it on your own, whatever name that you want, XYG. Okay. Now to do that, we need a tool. We need a labeling tool. We need an annotation tool, which is going to help me out in this entire process. So how I will be able to get that tool? Like I said, so there are multiple tools which is available in a market, but what I'm going to use is as a label IMG. So if you will go to Google And if you are going to search for a label img GitHub, so you will be able to find out a label img GitHub, right? You will be able to find out a label img GitHub, a multiple GitHub you will be able to find out where people are maintaining this. Even you will be able to find out a label img PyPy package, as simple as that. So you will be able to find out label img PyPy packages over here. So maybe I can try to do a pip install label img, and latest version is also available, they are saying. So here these label img is going to do what? So they are going to help you out in terms of creating these kind of a labels. As you can see, these kind of a labels, right, for any kind of a custom images. And they have even given you the installation step, basically like a conda installation and all those things. But what I will do is I'll just go to my environment and copy and paste pip install label img, and let's see what happens. There are some changes you will have to do because there is a issue with the code that people have given inside a label img, which I'm going to show you very soon. So pip install label img and hit enter, guys. And in some time, in no time, basically it will be able to install a label img, right? So you must be able to see a label img in your respective environment. I'm able to install it. I'm able to install this one inside a label, this YOLO environment. Is it done, guys? Are you able to install label img tool? Yeah. So just do pip install label img on a GitHub repository. If you will go, you will be able to find out multiple processes that they have attached, but it's completely fine. Avoid it. I'll tell you what is the changes that you'll have to do. Yeah. So just do pip install label img and confirm me yes. Now, once it's done, right? Once this label img installation is done, then do one thing in your same console, right? Type label img, the tool that you have installed, just type and hit enter, and it is going to pop up this kind of a box. So label img tool, it is going to pop up. Just type label img, only label img you have to type. Yeah, only label img. Okay, done, everyone? Now, so my data set is available at D drive, YOLO, custom, brain tumor, train images. At this place, my data set is available. Now, this is the tool which I'm able to see. Now, just click on open directory. So this directory, open directory, and I'm going to browse my image, by the way. So YOLO, custom, and brain tumor, and then train, and then images, and then select folder. Now you will be able to see on your right hand side. So you will be able to see on your right hand side that it is showing you all the images. I have selected the folder and it is showing you all the images. All the images means whatever images was available in that folder, it is showing you all the images, raw images, not a label, just the images it is trying to show you. Yeah. So just the images it is trying to show you. So here, these are the images which is available to me. Now what I have to do, I have to label those images, right? I have to basically label those images, that whether this image is having a tumor or this image is having a no tumor, right? So this image is having a tumor and then no tumor. So I have to label all of these images. I'm not going to label all of these images because it is going to be a tedious task. So maybe 10 or 20 images I am going to label so that I will be able to do a training, and at least I will be able to show you a basic, right? I will be able to show you a basic of it, basically, right? So this is something that I'm going to do it. So to do this labeling, what you have to do is, so here, I think you must be able to see my cursor, right? So here you will be able to see a Pascal walk. If you're going to click once again, you will be able to see YOLO, right? We are going to use YOLO model, YOLO architecture. So you will be able to see YOLO. Click once again, you will be able to see create ML. Click once again you will be able to see Pascal walk. So there are some model which supports Pascal walk kind of a labeling. There are like a YOLO series, one of the prominent series, which supports a YOLO kind of a labelings, and then create ML. So we are going to train a YOLO model. So we are going to select YOLO so that whatever label it is going to create, so basically that particular label will be having a YOLO style of a labeling, like a pattern, basically. So where there will be a class name and then there will be a coordinates, 4 coordinates. So okay, try to select YOLO, and then you will be able to find out something called as create a rectangular box just below this one. Create a rectangular box. So select it, and then try to, you will be able to find out this plus, right? And now it has crashed. This is the actual problem with the label IMG. It has crashed. So basically you have to do a little bit of changes in a original label IMG file. So wherever this label IMG file is been downloaded, so little bit of changes you have to make, because once you are going to select, it will keep on crashing, and that is a known issue for a label IMG. So what is the changes that you have to do? Let me show you that part as well. So there is a file number, so there is a file. Inside this file there is a line number 526, 530, 531. So those files we have to change inside a label IMG. So here it is showing you this error that at this particular place, right, at this particular place, canvas.py file, so this 530 line number is crashing whenever I'm going to click it. So it's clearly visible. So what I will do is I'll just go to this path. Now for path for you will be different because you are going to get a different issues. So I'll just go to this particular path. I'll open up my file path browser, and then here we have a canvas file, right? So inside your environment, you have basically downloaded this like a label IMG, right? You have downloaded this library, which is a label IMG. Now inside that there will be a canvas file. Right click, and then you can try to open up anywhere. So maybe open up with the VS Code or maybe any text editor, even notebook, that's completely fine. So I'm going to open up with the VS Code. And now here, once you will come inside this file, canvas.py file, so come to line number 530, and because of that, it was crashing actually. So there is a little bit of patch that we have to like do over here. So in line number 526, because I have done that, and in line number 30 and line number 31, because once you are going to fix it for line number 30, it will start giving you error for line number 31. And once it will start giving you error for once you are going to fix line number 31, then it will start giving you error for a line number 526. So we are going to fix all of these three so that it is not going to give me an error, and it should allow me to label my images. So this is the little or a small patch you have to do in their original library itself, a label IMG original library that you have installed by doing pip install label IMG. So what kind of a patch you have to do? Let me show you that. I have done those patches for me, by the way. So this is my current, this is my previous one. And this is the known issue, so no need to like worry about anything. Canvas, and then open with maybe in a notepad++. So I have already done the fixes, by the way, for this one. So in line number 526, this is the patch that I have to make. I'll show you. So here, line number 526, basically replace this line, right? This line with this line. Let me ping you this. Line number 526, guys, this is the first replacement you have to do. Otherwise, your annotator is not going to work. So first fix, and I'm going to give you like a canvas.py file as well while uploading this entire code. And then for line number, this 31 and 32, whatever is available at 31 and 32, you have to replace it with this one. Means now it will become 35 and 36, by the way, because this has taken a lot of lines. So now it will become line number 535 and 536, and just replace with this two piece of a code carefully, right? Carefully just replace it. So the way I have done that, right? So line number 530, here you have to give this one. After previous replacement, it will become line number 535, by the way. And then here you can match the code and then replace it with this, and then Control S, save it, right? So in this way, we have just created a patch, and the label IMG file, which was giving me an error. So I have just like fixed that particular error so that now it is not going to crash. This is the known issue if you're going to search over the internet. So whoever is going to use it, they are facing the same issue, and that's the reason. So this patch, you have to do it. So the people who has released this label IMG officially, they have not resolved it. I don't know why. This was very small for them. Maybe they would have done that, but yeah, they have not done that. So we have to do it at the time of coding. Is it done, guys? So now it should not crash. The way it was crashing at line number 530, it should not crash now. Is it done? Are we able to patch it? Label IMG. And here you will be able to find out. So error itself is going to tell you that where is the file. And you can even find it manually. So wherever you have created this YOLO environment, right? Your virtual environment. Inside that library side package. Done, everyone? Yeah. Shall we launch label IMG once again? So now launch once again your label IMG tool. Now again, you will be able to see the same pop-up. Again, you have to go to open directory, dataset IMG training, and then maybe select those dataset. I think I have selected the incorrect folder. D drive, and then YOLO custom, brain tumor, training, image, and then this one. Yeah. So now my data set is selected, and now if I'm going to select YOLO over here, right? Because we are like labeling it for the YOLO model, and then create rectangle. Now you will be able to find out this smooth hover plus, right? A smooth hover plus you will be able to find out. And if you are going to drag it, right? If you're going to drag it, so you can drag it for the very small region, you can drag it for the whole region, whatever you want, you can try to drag it for this one, for this much, you will be able to drag it. And it is going to label it the way you want in whatever like a rectangular shape you want, you will be able to label it. So even a small region or even a big region, you all will be able to label it. Yeah. And now, so here you can try to give your label. So no TUMOUR. Now it is not going to crash. So no tumor. Right. So no tumor is one of the label I have created. Now, if you are going to do Control S, right? Control S. So what it will do is in the same image folder, wherever you have selected your images, in the same image folder, it is going to create a file with the same image file name, but extension is going to be TXT. Now save it. Extension is going to be TXT. I'll show you what I have created. And this is the label, guys. See, this is the label. I can even try to like, if I would like to change it, I can change it in a later stage, right? I can change it in a later stage. And again, I can do Control S. Now, so it has created a file TXT basically in the same folder. So, okay, I'll go and I'll try to check. So whether that file is available or not inside my like same folder. So here you must be able to see that it has created a file with the image name, whatever image that I have taken. So with the same image name, so it has created a file. Now, if you will look into this file, right? If you will look into this file, so it has done what? It has given a class. So 0, 1, 2, 3, 4, 5, 6, so on for its own reference. It will try to give a class, and then there is a coordinate, a 4 coordinate, because it has created a boundary boxes, right? A rectangular boundary boxes. So 4 coordinates are available. And then there is another file called as classes. And this is representing my class. That 0 means no tumor, right? 0 means no tumor. So here the reference of 0 means no tumor. If I'm going to label it with some other classes, it will try to even maintain that particular class over here. Now this is the file I have to take. This is the file I have to create. So when you have downloaded this, right? This is what you are able to find out. See? This one, right? And then like 10, 10, 10, they have labeled it with the 2 classes. I can label it with the multiple classes. So whatever you are able to get here, I'm creating it manually. Someone has done that. Someone has basically created this entire file. So now I'm able to create it also. See, same file I'm able to create it with my own label. My label is no tumor. Their label was positive, negative, right? So whatever. Now, again, I'll go to my label IMG. So one image is done. Next image, by the way, next image. So maybe I can label it this one with the tumor. So here I can select it carefully, and then I can say that TUMOUR, tumor, right? So tumor, and then Control S, save. Now, again, next image, again, I can try to label it as a tumor. This entire region, save. I can create any number of like classes. So here again, next, save, right? So save, and then again I can try to like draw the rectangular boxes, and maybe I can try to label it. So I can select the class, guys. See, by default the previous class will be selected. I can select the class. So which label I would like to give to this one, this particular box basically, right? So tumor or no tumor. So I would like to give like a tumor to this one, right? In the same image, if I would like to create a multiple label, simple, right? If in the same one I would like to create the multiple label, this region, 2 label I'm creating, right? And I would like to give that as a no tumor. Fine. So in the same image, I'm able to even give a 2 classes, or maybe like a small multiple patches I can try to create in the same one. As many patches as I want, I can try to create. Maybe this region is representing a tumor, so I can select a tumor over here, right? So in this one single images, basically I'm trying to do what? So I'm trying to basically create a 3 labels, as many labels as I want. There is no restriction with that. So I will be able to create it. Now if I'll go and check, right? So here train, then images, and here, so you must be able to find out that it has created 3 labels for this one, right? This is what I have done. 3 labels I have created, and then this is the name I have given, 101, and with the help of class reference file, it will be able to understand the actual name, that what is the meaning of, what is the name of 1, what is the name of 0, what is the name of 2, 3, 4, 5, or hundreds. So I can label hundreds, thousands, or maybe a millions of a different object. It will keep on giving a numbers, and then in a class file, it is going to store the name, a reference name, that okay, that's a reference. Because now if you will go and check your class file over here, so at 0th position, no tumor. At first position, so this is how it always try to follow the indexing. So at 0th position, there is a no tumor, and at the first position, there is a tumor. Yes, making sense, guys? Yeah, any one of you are able to do the labeling? Okay, Joey is saying, can you please give the canvas file? Okay, let me give you the canvas file, which is like not going to crash. So this canvas file, maybe I can try to like edit, open with VS Code, because without this modification, your label IMG will keep on crashing. Okay, fix the code, right? Okay, if you have fixed the code, then it's completely fine. Otherwise, I have just pinged you the like a whole piece of the code. Just copy it from your chat and then paste it. Copy paste. That's it. Yeah. So how many of you are able to label your image, guys? So see, guys, this is how training happens. So labeling generally like we just give it to the interns. We don't do it because it's kind of, as you can see, repetitive task. There is no fun in this after some time, right? There is no fun at all. So yeah. So my maybe I can go ahead and I can try to like label couple of more images. Let me label this one as a tumor. Okay, then save it. Save the next image. Maybe here I can try to give a small label, tumor. The next image, save it. Save it. The next image, no tumor. To this one I'll give. And maybe I'll give a tumor to this one. I'm not a doctor, guys, so don't expect me to like identify a tumor and no tumor exactly. I'm just trying to teach you object detection in an engineer's way. So don't come and tell me that you have labeled wrong. I'm not a doctor. I'm just teaching you like how to identify any object in anything. Okay, so maybe I can label it as a tumor. And labeling is very important task, guys. If your labeling precision is not good, then your entire training will go for the toss. This is tumor. Next. No tumor. Tumor. No tumor. Okay, so I think 5-10 images we are able to label, I believe. Let me go and check. Yeah, so I think 5 or 10 images we are able to label. So I think we are good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 11 like images we are able to label. So I believe I can go ahead and I can try to use a label and its respective images. Yeah, label and its respective images. So once this is ready, now same thing you have to do for all the 100,000s of images. And that's the reason. So if you will go and check any of this repository nowadays, people have already uploaded a data with a label, right? So labels are already available even in our data set, as you can see. So all the labels are available for all the images. Someone has already done this task for me, right? So you can try to use this file directly, but I'm not using it because I have to show you a custom training. That's the reason. So I'm not using it. Otherwise you will say me that now how we can label it. So you have not taught that particular part, right? So now we are able to do the custom labeling. So I'm good. I'm happy. Only 10 images. Obviously my training is not going to be that great. I know about it because I have a very few labeled images, but still I can do the training. I can run the training now. Okay. So label IMG is done. Now what I will do is I have to basically place all of these images into training validation and labels into training and validation, right? So image folder, we have to place images. Label folder, we have to place the labels. Okay, I'll start doing it. So let me like minimize this window a little bit. Okay. So here is my image. And again, be careful. So image name, label name. Like image name, label name, image name, label name, image name, label name. Otherwise, it will not be able to understand much, right? So I can select this image. I can select the images for which labels are available. So 1, then 2, and then 129, then 147, 239, 102, and 141, then 179, then 84. Okay. Okay. So I'm going to take these images, right? I'm going to take this image, only images. I have selected only images. I'll drag and I'll drop it inside the train folder. You can copy and paste any way that you want. So inside the train folder, I have like dropped all of these images, image and then train folder. Okay, close it. Now labels, right? It's time for labels. So try to select the corresponding labels. So define this, and this. Okay. Now drag it inside the train labels folder. Okay. So now images are available, right? And the respective labels are available. As simple as that. Respective labels are available and this images are available. Fine. Now for validation, we can try to keep couple of images, right? And like its respective labels. So I have something left. So 1, 2, and 3. So this I'll try to put it inside the validation folder, image. And then 1, 2, and then 3. So this I'll try to put it inside the validation folder of the labels. Fine. So now I have a training data. I have a validation data, image, simple, right? And then training data and validation data with respect to the labels, simple. Is it making sense to all of us? Are we able to maintain it? Everyone? Yeah. Are we able to maintain it? Done, guys? So this was the main task. After this task is very easy. Believe me, very easy. After this, actually nothing. And this main task has been done by freshers, by the way, interns. Okay, so once this part is done, right, then we can start doing a preparation for a training. So whatever training that we have to do, so we can start doing a preparation for that. So let's do it. Then once this entire data set is available to us. So maybe we can try to create a requirements.txt file. So here we can try to create in a main folder, requi requirements.txt file. Okay. Now inside this requirement.txt file, keep all the packages that you have to install. So these are the packages that you have to install. I believe all the packages are known. Ultra Analytics for giving you a YOLO. Open CV, Python, NumPy, Matplotlib, Pandas. Now what we are going to do is, guys, we are going to do a transfer learning. Transfer learning means, so there are models which has been trained already. We are going to modify its weight as per our own label. So there is already a model which is basically a trained on some of the data set. It's already having a weight, for example, YOLO 8 that we have used last time. We can use that. We can do a transfer learning means we are going to modify it with respect to our own label, with respect to our own data set. How? Let's do it. So requirement.txt, and first of all, go to your environment. So select conda activate conda. So conda activate, what was the environment name? I think YOLO env was the environment name. Okay. Now just install this requirement.txt file. So pip install -r requirements.txt. So it will install all the required file inside my folder, inside this environment. So do it, guys, everyone. Okay, so this installation is done. All this file installation is done. I can just clean it, CLS. And then what we have to do, so inside this dataset folder, the dataset folder that you have created, right? So you have to basically create a configuration file. You have to create a like a YAML file, basically YAML file. So which will be able to make understanding about the classes and the paths and the training and the validation. So here, just inside the dataset folder, just create one file called as data, right? Data.yaml, yet only markup language. This is the file extension. So YAML file. So this is the place where we are going to keep all the configuration with respect to the training. So in a very first place, we are going to create a variable called as path, path variable. Now what this path variable is going to keep? So basically this path variable is going to keep a path of a data set. Now my data set is here. This is the data set. Now what is the path? D drive YOLO custom training / data set. So I'm going to keep this path over there. So here I can try to like click on copy path, and then I'm going to paste it here. And if you're using a Windows, so just change this /, so /. So here, now this is going to tell me that, okay, so at this path, my data set is available, image and labels. Data set is available, right? Image and labels are data set. Okay. Now, so the second thing is train. So where I'm going to keep my training data, right? Where I'm going to keep my training data. So main path is this one. So my system will be able to reach out to this main path, this particular path. And then inside this particular path, where is my training data? So where is my training data? Basically, IMAGES images / train. So inside this images folder, inside that train folder, I have TRAIN train folder. Inside that, I'm going to keep my training data. Now where I'm keeping my validation data. So validation data, I'm keeping where? So inside the images folder, IMAGES images folder, I'm keeping my validation data. So in this way, I'm just trying to make my system understand, my run understand that, okay, so here is my image train. So whatever folder structure that you have created, just keep that path. Like not necessary to create the same folder structure. You can keep it anywhere you want, but yeah, you have to maintain the path over here inside your configuration file, inside your YAML file. Now, you have to create another variable called as number of class. So how many classes you have? You have 2 class, so that it will be able to understand the indexes 01, 01, 01, right? And what is the name of the class you have given? English name of the class you have given. So NAMES is the variable you are going to create. And then inside a list, whatever number of classes that you have created, means here I have created like 2 classes I have, right? A tumor and no tumor. So you can try to give it index wise. So one class is no TUMOUR. I believe this was the class name I have created. I can go and check. No TOMOUR, no tumor, no space tumor. And then another class which I have created is TUMOUR, right? So tumor and no tumor. So these are the 2 classes I have created. No tumor was having an index 0 and tumor was having an index number 1. So in this way, I can create hundreds of classes. Simple. So number of class is equals to 2. Space is required. Otherwise, it will give you error. It will give you red. So this is the YAML file, guys, you have to create inside a dataset directory. Always inside a dataset directory, you have to create the YAML file. So now let's try to create it. I'm pinging you my location, but you should not copy and paste my location. If your location is different, it will not work. As simple as that, it will give you the location error. So someone is saying, Mohit is saying, what is the use if we are creating data.yaml file? I mean, this is the use. Yep. So data.yaml file we have already created. Okay, this is done. Now move ahead. And then now let's try to create a training folder, a training file basically. Now we can like write a training and we can start doing basically a training over here. So just I'll come out of this entire things, right? I'll just try to come out of this entire things and then I'll try to create a training. So here, maybe I can write a train.py file. It's not dot, it became comma, rename it. Train.py file. Okay. Now inside this train.py file, I'm going to write a training, which is like a 3 to 4 line of a code, not more than that. It's a very easy to do a training. So from ultra, 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 LYTICS, import, basically what? Import YOLO. The file that we have already installed, alternatives we have already installed, and even we have used it last time. And then model is equals to YOLO, so that it will be able to download the model structure. And model structure wise, you have to use YOLO 8. You can try to use. Again, inside the YOLO 8, there are multiple versions that they have. You can use any of these. So YOLO 8 PT file, you can try to use. And then model.train, model.train. So the model that we are able to download, so this will download from the Ultra Analytics. From Ultra Analytics, it is going to download this model. You will be able to see that model over here in your path as well. And then here, so we are going to say that, okay, so data for this model is available is available at this place. So we are going to give a path of data.yaml, because data.yaml we have already mentioned dataset path. So we have to give this path. So copy the relative path and then this is the path I'm going to give. So this is the path for the data. So it will go and check my data.yaml, and from data.yaml it will be able to navigate to my train and validation. As simple as that. Now I can try to give a epoch. So for just like we try to do it for any other models. So EPOCHS epoch, maybe I can give it 50 for as of now. And then IMG size I can try to give. So I can say that, okay, fine. So on an average, my IMG size is going to be 640. And then I can try to give a batch. So batch is equals to maybe 816, whatever I want, I can try to give. These are just a hyperparameter. So I can change it, right? So here, right? So here what it will do is it will start doing a training of your model, right? It will start doing a training of your model. Now, once it will be able to do a training, right? Once it will be able to do the training, only this line, right? Then we can try to export my model. Export my model means we can try to save my model. Okay. How I can save it? So I can try to call model.export, model.export, and then export my model. I can give a format. So FORMAT format is equals to, I can give a multiple format. Maybe I can give ONXX format, ONNX format. So in this format, it is going to save the model. Now this is the only thing which is required for a training. If everything goes fine, it will start training, believe me, and you will be able to see a model here. So let me give you this code so that you can start your training. Only 3 line guys, just 3 line, right? With no logic, I would say. So here, dir, I think I have train.py file here. Yeah. CLS, clean it, then Python, train.py file. Hit enter. If everything goes fine, it has started downloading. And yes, we are able to see YOLO 8 and PT. This is a model which it is downloading from Analytics. And as you can see, it has started training my model. See guys, just in 3 lines, we are able to do the training, right? So main thing was like a preparation of the data. This is how easy training is for any model, believe me, right? So even for a chat GPT, it's just like a couple of lines of a code and you will be able to train the things. So data preparation, those pipelinings takes all the times. Otherwise, training is not a big deal. So are you able to start your training, guys? Yeah, are you able to start your training? Anyone? I'm able to start my training. So as you can see, it is training on my class name. So tumor, no tumor, no tumor, whatever classes that I have given. So image, instances, box, and then like MAP, MAP50, R. Yeah. So yes. Okay. Joey is saying yes. Fine. Now my training is done. It was a very small set of the images, first of all, and then I have just trained for the 50 epoch. So my training is done. Now I can even visualize my model at Neutron app. I believe I talked about a Neutron app, right? So Neutron app is a platform, so where you can drag and drop your models, and then you will be able to visualize it. Now, where is my model, by the way? So as you can see, I have done the export of the model in this format. Okay. Now you will be able to find out that automatically it has created one folder called as runs folder. You have not created it, basically. It has created automatically. So this was the raw file. This is the model which I have trained actually. So inside the runs folder, you will be able to find out there is something called as a wait folder it has created. So click on wait folder. Now, so inside this wait folder, you will be able to find out basically a best.pt. So this is your like final model, right? This is your final model after this like a 50 epochs. This is the model that it is able to create. Now I can try to drag and drop inside my Neutron this PT model. I can try to like drag and drop, and maybe I can try to see what is the structure of this like a PT model. So what is the file location? So D drive, YOLO, custom training. D drive, and then yeah. So now I have just loaded it inside my Neutron app, right? And this is the model size that you will be able to find out. So it's a big model. It's a very, very huge model that we have trained. So the transfer learning that we have done, as you can see, right? And you can go ahead and you can try to observe each and every point, each and every layers if you want, what kind of a modification as a part of transfer learning that we have done, what is happening inside it, each and everything you will be able to observe it with the help of Neutron.app. This is an online app, right? So just for the model observation. But yeah, my objective was to get my model, and I'm able to get my PT model. This is something that I can try to use for my like a prediction. This is something which I can try to use for my detection basically. And apart from that, so it has created a confusion matrices chart as well, right? So for tumors and no tumors, so it is giving you a complete detail. So like while doing a training, so what was the noises and what was the basically like a confusion matrices. It is giving you a very clear confusion matrix for everything, right? So for every matrices, F1 curve, it is going to give you that how my confidence curve for tumor and no tumor looks like while doing a training, right? And then like labels. So how many data set we had for a tumor and how many data set we have for a no tumor, and then what it has done internally, right? What it has basically done internally. So you will be able to find out a lot more detail. Means whatever like is required for like a observation. So precision confidence curve, and then like again, so precision recall curve, recall confidence curve, everything you will be able to find out in a beautiful manner. And then here you will be able to find out that how my training has happened and what was the matrices. So, and how this matrices has actually moved with respect to a different epoch. Simple, right? And then like when I was trying to do a training for a batch 0. So we have like 8 batches, right? So we have given basically like 8 batches. So see, this is how internally it is trying to do a training with my images, right? It is able to like, this is the classes 10, 10, 10, right? This is the classes, and this is coming from my images, right? In some of the images I have given 2 labels. In some of the images I have given just 1 images. So every detail, guys, every detail you will be able to find out, right? So is it not amazing? Yeah. Every detail. So whatever it has done while doing a training and while doing a validation, you will be able to find out. Yes, so validation looks good to me. So wherever there was a training, wherever there was a tumor, it was able to label it as a tumor, and wherever there was no tumor, it was able to label it as a no tumor. So it looks amazing to me, by the way. Yeah, and again, you can download the entire CSV file for the entire 50 epoch. So if we have done 50 epochs, entire matrices, entire CSV file, you will be able to download it for the observation that how your training loss is trying to decrease or increase, or how what is the parameter that is changing during a training with respect to a precision recall. So whatever images that you are able to see, all the details is coming from this CSV itself. Yeah. So complete detail about the evaluation you will be able to find out. So whether your training was a good training, bad training, or maybe a substandard training, everything you will be able to observe as a techie from this particular file runs, and then inside that you will be able to find out all the other files. Plus, so you will be able to find out arcs.yaml. So here you will be able to find out all the matrices which YOLO has taken by default. You can try to change this matrices. You can try to even play with these matrices, by the way. Yeah. So model wise, it has taken this one. Data wise, it has taken this one. Epoch wise, I had given basically 50 epochs, and batches wise, I had basically given 8 batches. Image size was I have given this one. And I can play with not just this many things. I can play with all of these things for a couple of parameters. I have given the value, but I can give a value for all of these parameters. So just imagine how many things we have in terms of doing a fine tuning, in terms of creating a best of best models, right? So a lot of parameters which I have under my control, so which I can use it if my training goes south, by the way. So we are able to do a training. We are able to do observation. Now it's time to do even inferencing, right? Inferencing means let's go ahead and test the model, right? Go ahead and test the model means pass some images, pass some of the images, and then see whether it is able to detect a tumor or it is not able to detect the tumor by drawing the boundary boxes. Okay. So how I can do that? Maybe I can just try to create one more file over here, and I can name it as a test.py file. I can write my testing code over here. Is it fine, guys, till this point? Yeah, everyone? So here I can try to import. So from, first of all, I have to read my local model, the model that I have, ultralytics, import YOLO, and then from PIL, so that you can read the images. Import images, not image sequence, just image. Okay. So first of all, I'll try to load the model. So my model is basically YOLO model. YOLO will be in caps. YOLO. So I'll try to load my YOLO model. Now, where is my YOLO model? So my YOLO model is available inside runs, inside weights, and then this is the model, best PT. So I can just right click and then copy the relative path, or maybe copy the absolute path. Anything works for me. So this is my model. My model is available at this place. Maybe I can just try to change the slash for Windows. For Mac and for Linux, you don't have to do it. Yeah. So this is going to load my model, the model which I have trained with my own custom classes. And then I have to pass the data and I have to do the prediction. Okay, fine. So here I can try to do one thing. Model, I can try to call the model which I have loaded, and I can try to pass my data. So let me pass some of the data which I have not used, by the way. Okay. So maybe I can take this data. This is the random one, right? Right click and then let me copy its path. Path, where is the properties? Yeah, properties here. And then security and then details. Okay, so here is my path. This one images and file name is 61.jpg. Okay, so I'm going to copy one of the image and then slash 61.jpg. So this is my image. I don't want to change slash, so let me keep it R formatted string. It will keep it once again. So model, and then it is going to basically like I'm just trying to pass this image into my model. I can even pass a camera feed the way I have done that last time, right? But I don't have like an image with me. So with the help of your camera feed in a real time, you will be able to observe it by passing these images anyway, because now model is ready. So you can try to do a inferencing in real time in any like a near real time, or just by passing the images. Now I'm going to say that confidence score. So if confidence score is 0.1, means 10%, even if you have confidence score, show me the boundary boxes. I'll keep on changing it accordingly, because my model, I'm assuming that it's a worst model. Save true. So save the images and then show me the images also, TRUE. And yeah, so Control S, and then here I'm going to execute dir. I have a training test file, Python test.py file. Yeah, so now it is like showing me that okay, JPG 640 cross 650, no detection. It is telling me that no detection, and this speed was this one, inference was this, Postgres was this, per image shape this, result save to run, detect, and then predict. So inside runs, inside predict, this is my image, and I'm not able to see any kind of a boundary boxes, right? Because my training was worst, and the confidence threshold which I have given, so maybe it is not able to surpass that confidence threshold. What I will do is I'll try to make it 0.1. Now you will see the boxes. I'm just decreasing my threshold, confidence label. And now you will be able to see. And see, now the result has changed, and warning environment, this. The function is not implemented. Rebuild the library with the Windows fine. Image 61 JPG. No detection again. Result save, detect, predict 2. Let me make it even below this. Do we have prediction? Okay, now we have prediction, no tumors, right? Now we have a prediction, no tumors. Now if I'll go here, and maybe if I'll try to check my like current images, a lot of boundary boxes it has created on my images, a lot of boundary boxes, right? Because what I have done, I have just changed my confidence interval, right? I have just changed my confidence interval, saying that, okay, fine. So even if you are this much confident, 0.001% confident, just like do the prediction, just do the boundary boxes, and it has done the boundary boxes, no tumor, no tumor, no tumor, no tumor. The only reason was that at the time of training, I have taken the very less number of images and validation as well. So very less number of images, I have labeled it, and even I have trained it for the very less number of epoch. But yeah, successfully, if I'm dropping my confidence label, right? If I'm dropping my confidence label, if I'm going to increase it a little bit, so maybe 0.009, so my number of those checkboxes will decrease. Let me do the inferencing once again. Yeah, so no detection. Okay, so at 0.99, again, it is telling me that no detection. There is no detection at all. Maybe I can drop it to 7. So yeah, my model is worst. Obviously, I agree with it. No tumor. It is able to detect 11 tumors, and 11 tumors it is able to detect. See, it is telling me that. So in 11 places, I am able to detect basically tumors, right? Clear answer. I can go and check my image as well. So 61 JPG in a which folder it is trying to keep? Predict 5. So predict 5. Okay. So now a clean box, little bit of clean box, right? Even in a blank area, it is detecting some no tumors with this much of confidence. So are we able to see that, guys, that how we are able to like do a training, and then how we are able to do a prediction? We are able to do a prediction, by the way. I mean, like, it's a bad one because the number of images was very less. If I could have taken all the images which I have downloaded, then obviously my model will be a solid model. So even with a 0.9 confidence, it will be able to do some prediction. Making sense, guys? Are we able to do a custom model training and a testing? Yes, everyone? Yeah. So here is the result. So the way I'm trying to train this one, I can train now like for hundreds of use cases. If increase more epoch and batch size, will it increase accuracy? Not much, I would say, because your training data itself is very less, right? And when you are trying to do a testing with the complete unknown data, obviously it will get confused. So it's better to look into the data first. It's not like with 2 images, you will be able to build the best of best model. That is practically impossible. So I'll not say that play with the epoch and batch size unless and until you don't have a sufficient number of images. Image that too with a different contrast, a different rotation, different angles, all of these things plays an important role. That's the reason. So sometimes when we have like not a sufficient amount of images, we do a lot of like a fake image generation, and we do a data augmentation over there, image augmentation over there. We apply all of those processes so that my number of images will be like increase. My number of scenario will be increased because model always would like to see all of those scenario. Okay, as Yuri is giving you an answer, experimentation is a key. Can we do it with a live video? Obviously, you can do it with a live video. See, I have already done that. I think even last time in my last class, I have already shown you that how to do a inferencing with a PT, right? YOLO PT model. Now you have YOLO PT model. Just use the same code. Do the inferencing with the live video. Maybe keep images in your mobile phone and then show that mobile phone. It will work. It will work. You can try this out now itself. Like I have already given you the code in my last class. Just change the model. That's it. So use the model that you have trained just now. Okay. So model training and everything is done. Fine. Now what we are supposed to do is, so let's suppose if I have to like build an API so that, I can host this model anywhere I want. So let's go ahead and let's try to build the API for this particular model. Right. So now I'll try to teach you that how you will be able to build the API and how you can try to maybe host this entire models. Shall we go ahead, guys? Yeah. So here I will try to create a fresh directory. Basically your tumor underscore YOLO underscore API. So this is the folder I'm going to create. Now here I'm going to teach you that how you will be able to, like create an API for your model. And then eventually you can try to push it inside the GitHub repository and make it available to everyone. Everyone means literally everyone after doing a hosting, after doing a deployment, so that anyone, everyone in this entire world will be able to use it. Because as of now, it's available inside my local, right? So let's do it. Inside this, so I'll try to give you the structured way, basically. So here, inside this tumor YOLO API, I can try to create a folder called as app. Now inside this app folder, I'm going to create a file called as main.py file. You can give any name, but yeah. So for a reference, I'm giving you like a main file. And then another file you can try to create. So YOLO v8 underscore handler handler dot py file. Again, you can create any file with any file name. So there is no like a boundation with respect to that, by the way. Yeah. So main is available here. This is available here. Now inside this tumor file itself, so just try to create another folder called as wigsts weights. So weights, just try to create it over here. Now inside this weight folder, right? Inside this weight folder, try to keep your model. So where is my model? My model is available inside this run directory. Inside run, I have Okay, let me collapse it. Weight is available inside this tumor API. Fine. And where is my weight? Train weight. So this I have to copy. So copy it. And I have to keep it in my new folder where I am trying to create the APIs. So paste it. So now this weight is available. So I'm just trying to create the complete fresh project, you can say, right? So this is the fresh project which I'm trying to create. So tumor YOLO API, and here, so there is an app folder, there is a weight folder. Inside that, I'm trying to keep a weight. That's it. And then try to create basically, try to create inside this tumor YOLO API, requirement.txt, REQUIREMENTS.txt file. So that whenever I'll have to deploy, I will be able to deploy it. So these are the files, these are the things that you should keep inside the requirement.txt. I'm going to convert everything as an API. We can also use augment here. Obviously, you can try to use an image augmentation here, div. Okay. So this is done. Requirement.txt we are able to create. And if you're getting confused, guys, then try to take it as a separate project, right? Try to take it as a complete separate project, means try to open up a new instance of VS Code and then start creating this one. It's a complete like a separate directory which I have created, right? Nowhere related to the previous one, nowhere related to a training and testing that I have done so far. It's a fresh folder which I have created here itself. Inside that we have a app file, we have a weight file, we have a requirement.txt file. Inside the weight file, I'm trying to keep a model that you have already trained because I have to host this model, requirement.txt. So at the time of hosting, whatever is required, I'm trying to keep it here. That's it, nothing much. And then basically you have to create a file for this YOLO. So you have to create a file called as render render.yaml file you have to create. And then you have to keep all of these things which is required for running this entire one, right? That it will be able to build it with the help of this and it will be able to run it with the help of this. So this render.yaml is required for your hosting. So just try to create this one. Yeah, just try to create this one. And then inside this, keep this entire file in this way, render.yaml file. So you can see simply like we have a requirement.txt and then here we are trying to invoke our app actually, right? Okay. So render.yaml is done, requirement.txt is done, model we are able to keep. Now, so what we are supposed to keep inside a main.py file and what we are supposed to keep basically inside the YOLO 8 handler. Nothing, a very simple piece of the code. So a piece of the code which is going to expose my entire model basically. So inside your YOLO handler, you should keep this one. So where you are loading your model, a best.pt which is available inside the weight folder, right? Inside the weights folder which is available, and then predict images, right? Predict images. So here you are going to pass the images. It is going to call the model. It is going to send you the result. So this is going to give me the final result, as simple as that. Now, so this is just for the prediction. So once it will be able to give you the result, means the result that you are going to get and the result that you have received just now, inside a main file, we are going to convert everything as an app, basically as an app. So how we are going to convert it as an app? Let's do it with the help of Fast API. I can use even a Flask. I can use even a Fast API. That's completely fine. So I'm using a Fast API. You can use any API framework. It's completely up to you. So here, what you have to do is, so first of all, the way I believe we all know Fast API. We have already seen that Fast API instances, even in my previous classes. So we all know that how to create a APIs, right? APIs. And what is the actual meaning of an API? I believe I have already discussed about it multiple times. So that's the reason I'm skipping that part as of now. Now here on a root directory. So this is a message you will be able to get. YOLO model is live. You can try to Sudhanshu YOLO model is live. I can say Sudhanshu YOLO V8 model for tumor is live. Yeah. So maybe I can try to so whenever you are going to hit the root directory, you are going to see this one. And then whenever you are going to call the prediction, whenever someone is going to call the prediction. So whenever someone is going to call the prediction, right? So it is technically going to open up the images, whatever images you are going to pass, by the way, and then it is going to call the predict image. Where is my predict image? Inside YOLO handle, right? So it will try to pass my images into my YOLO model, and then it is going to give me the boxes score classes, because this is what it is going to return, right? It is going to return the boxes, it is going to return the score, it is going to return the classes basically. And I'm trying to return it as a JSON, as simple as that, right? So whenever someone is going to hit this particular path, so technically I'm executing this one, means I'm executing my model, right? And then I'm trying to return box score and the classes with the help of APIs. It's very simple, right? It's very simple. Okay. So if it is that simple, then let's try to run it, right? Let's try to run it. So here to run this one, where we are, by the way, so dir, and we have to go into this folder, Tumor YOLO API, because everything is available there. So I can go inside this folder, cd Tumor YOLO APIs. Now if I'll do dir, so I'm able to find out something called as app file, render.yaml, wait file, and byte file. So as of now, render.yaml and requirement.txt is not required unless and until I'm not pushing it on a cloud, right? Unless and until I'm not pushing it on the cloud. These files are not required. Only files is required, which is a app and then waits, because app inside app YOLO handler is calling my waits file. So here, let's do it. So to execute this one, I can run uvcorn. It's my Flask, it's my like fast API app. So uvcorn app dot main. So go to the app folder, app.main, from app, and then hyphen reload. Now hit enter. Now, once I'm going to hit enter, now my model is live, guys. My model is live. And here, if I'm going to check this, okay, I have terminated it. Yeah. So if I'm going to like check this particular location, so let me go and let me try to check it inside the browser. So if I'm going to check this location, Stanshu YOLO V8 model for the tumor is live, right? So at least it is live in my local system as an API. Now anyone who is going to do slash and then anyone is going to do a predict, they will be able to find out. And even I can try to check their fast API docs, right? Fast API docs that predict, and then someone is supposed to like upload the images over here, and they will be able to do the prediction. Yeah, they will be able to do the prediction. So now let me like give you this piece of the code, and then I'm going to show you that how to deploy this model. So tumor YOLO, let me give you this complete folder. So D drive, YOLO custom training, right click, compress, and then zip. Yeah. So now guys, entire folder is available to you. So inside that you will be able to find out a custom training, as well as you will be able to find out my model. Plus you will be able to find out a folder where I'm trying to create the APIs. Yeah. So here you will be able to find out main.py YOLO handler. So just extract this, this file, tumor YOLO APIs. So where I'm trying to create the API and execute that part. So here the API is running. API is running, and technically I'm able to hit that API. Now if I'm going to pass images basically, so I will be able to, you know, perform, or I will be able to do the prediction. As simple as that. I'll do it in some time. So just give me a confirmation that are you able to do it, guys, till this point? Yes, everyone. Yes, are you able to do it till this point? Now I'm going to show you that how we can try to test this one with the help of APIs. How we can try to test it with the help of APIs. My model is live on this particular URL on a port number 8000. So as of now it's live, and how I will be able to basically do the prediction from this particular model. This is something how I'm going to hit this particular API. This is what I'm going to show it to you. So maybe I can try to create one more py file over here or anywhere else. That's completely fine. So here a new file and API underscore tsting testing.py. So now I'm going to do the API testing, whether my API is up and running or not. So my API is up and running at this URL as of now in my local, right? At this URL, my API is up and running. And yeah, so the path from where I will be able to do a prediction is this one. Means if I'm going to call this path, it is going to execute this function. This is going to execute this particular function. So, okay, let me call it. So import request basically, and with the help of request, I will be able to call this one. So URL wise, what should be the URL? So URL is going to be this. URL where my API is live is going to be this /predict. Now at this URL predict, basically this function is available, which is going to read my image, which is going to convert it into a byte, which is going to call my predict, and which is finally going to return me the boxes, score, and the classes. As simple as that. Okay. So at this URL, this is available. So here I'm going to read the image, one of the images or any of the images I'm going to read, and then I'm going to call this request. So here I can say that with open, right? With open, just doing a API testing, guys. And I'm going to take any of the images. So maybe I'm going to take this image path. So the file name I'll copy. So this image / file name is this.jpg. I'm taking again random image. So jpg. Now let me put R so that I don't have to change the slash. Okay. So I'm trying to open up this particular image into a read binary format as basically file. So this is what I'm reading the images, and then request dot post. So post it now, and post it with what? URL, the URL which I'm talking about, URL where my server is up and running. This particular server, the entire UVCon server, Flask API is Fast API is running, and then I can try to basically pass my file over here. So files is equals to basically key files file, and then this f, the f that where we are trying to load it. This is going to return me the response. Now once it is going to return me the response, maybe I can try to print it in my console. Print response.json, because it is going to return me the JSON response. So this is going to print it. So see, I'm doing a API testing, guys. So I'm hitting this URL. Now at this URL, my server is up and running. I'm not going to stop my server, as you can see, right? It's still up and running. So at my server, at this URL, basically URL means predict. So at my local machine, at predict, this function is available, which is going to read the data, which is going to call the predict model. As simple as that. Control S. Let me open up a command prompt, and let me execute this API testing file. So dir. So here do we have API testing? Yeah, API testing.py file is available here. Now, so I can do Python API testing.py file. And there is no boundary boxes it is able to observe. There is no score it is able to observe, and there is no classes it is able to observe. All these things are empty. I'll go and check 200 OK. Yeah, no detection. See, no detection, 200 OK. As simple as that. Now, if we have to do a detection, right? Even with the worst of worst scenario, so maybe I have to decrease my confidence score. The way I have decreased it over here. So maybe I can try to call this confidence score, and keep it here. Control V, Control S, and it is reloading my API as I have changed my backend server basically. Yeah, so reloading my APIs. Now, okay, reloading my API once again, and now CMD. Now test it again. now I'm able to get a result, right? Because I have decreased my confidence score, as you can see, right? My confidence score is 0.007, just like a previous one. So this time it is able to give me a lot of boxes. Hopefully it has given me 11 tumors, 11 boxes it has given to me, right? 11 tumor. And my model API is live. See, still it's live. If anyone is going to hit my API through my local, so obviously they will be able to get the same prediction. Now in a class, so guys, do you want me to use my API? This one? Do you want me to use my API? The API which is running in my system? Do you want to test it in your own local system? So maybe I can try to like create my entire system as a server, which will be like available globally with the help of ngrok. Yep. Okay, so let me convert. So this server is up and running, as you can see in my like a system. Right now, what I can do is I'll just I think I have shown that part like multiple times. So ngrok, let me open up my ngrok over here. I have already downloaded. Otherwise, I can just go and download it. ngrok download. Okay, Windows, I don't want to like do this. I want to download it. So ngrok, let me download in my download folder. I'm just trying to make my API globally so that API will run in my system. Keep your image ready. You all will be able to do a testing in your system. So I'm just going to make my server, make my system global. Replace with the file destination. Okay, so ngrok, execute. Why it is not working? It should work. Okay. Fine. I think guys, I'll have to restart my system to make it to work. ngrok. I think I'll have to restart my system. Okay, not an issue. So I have to make it global, right? So instead of making my local system global, let's deploy this app, guys. Let's make it global. Let's start doing a deployment, right? So let's start doing a deployment. So we can try to do a deployment on a render app, basically. So let me go to a render. Why I'm using render? Because it's free. It's give you a free credit. RENDER, render. So just go to a render. In no time, we will be able to deploy. Deployment is very easy. It's not a big deal at all. So go to render. I'll show you deployment, and every one of you will be able to make everything forever like a public, basically. So I can just log in. So just go ahead and log in, guys. They provide you a Google login option, by the way. Render.com. So just go to the render.com, guys. And then go to dashboard, and inside this, whenever you will go to a render, so you will be able to find out something called as this add new option. So you have to basically call up web services. But before that, right, before that, so you have to either Dockerize your entire solution, or you have to push your entire solution to the GitHub. Yeah, GitHub. So what we have to do is, we don't want to push everything. We just have to push this API part. That's it. Because this is something that we are going to deploy, right? Inside this API part. So we have basically a model. So I don't want to like deploy everything. I just wanted to deploy this one. Sorry, the API part I would like to deploy. So I'll go to GitHub. So I believe all of you have a GitHub. We have done that so far. So just go to GitHub, create a new repository. Within 5 minutes, guys, we can deploy it within 5 minutes if there is no issue then in that case. So click on new and then click on this repository and create a new repository. So tumor medi, any repository name you can try to give. And I believe so far we all are aware about our GitHub repository. GitHub is nothing new for us. And then we can try to push our code inside this repository. So once this repository is created, then do one thing. Go to your folder, dir. Now, this is the folder where I have all the code, right, for the APIs. So I have to deploy basically this one. So here I can try to go tumor and then I can do a dir again. Now I have app folder, render YAML, request, wait, all these things is available. Okay. So I have to push this entire folder inside my GitHub. Simple, right? I have to push this entire folder inside my GitHub. So how I can try to push this entire file into a GitHub? So GitHub is already giving you this steps. So first of all, GitHub git init, as we can see. So first of all, git init, and then so it has already initialized the GitHub, and then git add everything. So whatever is available inside my folder, add everything. So git add, that's the reason I'm giving dot, not readme.md as is been mentioned over here. I'm writing github.add. Then you have to write basically git commit. So git commit commit message if you would like to give. So this is my tumor file first time. Okay, so this is the commit message I have given. So git commit. So it has committed all the files, whatever files was available inside my like a folder. And yeah, so then git branch main m, same thing, right? So we don't have to like even remember these commands. Cancel git branch m. Okay. Then inside this branch, tumor medi, we have to push it. So let's push it, guys. Hit enter and then call final push. So if this is going to work, it simply means that it is able to push everything inside my GitHub repository. So yeah, it is able to push everything inside my GitHub repository. Now if I'll go and check, so if I'm going to refresh it, all these files is available. So just now I have pushed it. So my app file, and inside app, so I had basically YOLO handle main.py file, which is available. Inside my wait file, I have a model best.pt file, which is available. Inside this render.yaml, so I have an instruction that build command is this, and basically start command to start my server is this one. It's available. And requirement.txt is also available. So it is going to execute this entire things in a server, basically at the time of deploying this one. So my code is now available on my GitHub. Okay. So once my code is available on GitHub, I will go to render, right? I'll click on add. I'll click on web service, right? I'll click on web service. So click over here. Now it is going to ask you to attach your GitHub basically, right? Attach your GitHub. So it is going to authenticate, by the way. It is going to authenticate for the very first time. Now I have already authenticated it. You can again try to like attach some different like a GitHub repo. You can try to connect some different GitHub repo. That's completely fine. So I can click on disconnect credential and then I can disconnect it. I can connect it once again. So it's very simple. Just one click and then you will be able to do it. Now here after connection, so it is going to show all the public repository or private repository that you have. So as you can see, tumor medi is a repository which I have created. So I'm going to select this tumor medi repository, by the way, right? Name is tumor medi. If I would like to change my app name, I can try to change my app name. Language is Python. Branch is main. So yes, in a main branch itself, all of this code is available. So I'm going to consider this branch itself. I don't want to consider any other branches, by the way. And then here, So a root directory. So root directory is like a same basically. So root directory is not like a different for me. And then build command. So build command is basically pip install -r request.txt. This is the build command I have given. Inside this one, pip install requirement.txt. Start command you have to copy from here, right? Start command you have to copy from here, and then you have to paste it here. Unicon app main app this. So start command that I have mentioned, so that it is going to start your app. So the way I'm starting my app in my local system, this is also a system, right? It's a global system that I'm using. So same command is not different, right? So it is going to start. Then hobby project, choose a free one. So it is going to give you 512 like a RAM, and then this small GPU CPU it is going to give you. If you have any kind of an environment file, you can try to attach it, API key or anything. Otherwise, you can just try to leave it. So this is the only small configuration you have to do on a render. Apart from that, you don't have to do anything. If you are going ahead with the paid version, you can even scale the entire model, scale the entire infrastructure till any limit. So even if 10,000 people, 20,000 people, or maybe a lakhs of people are going to hit your server, it will be able to take a load. They are giving you a scaling. So they are giving you the scaling option. All the cloud provider gives the scaling option, but yeah, they are giving you with respect to a paid version. Yeah, with respect to a paid version. But yeah, in a real time, this is what we do in general. So now let's click on deploy web service, and then let's see whether I'm able to deploy it or not. So here I'm deploying my backend, guys, by the way, right? Here what I'm deploying my backend, not a front end. There is no UI I have deployed. I have deployed my backend code, by the way. Now, so the way I was able to test it, right? The way I was able to test it in my local, just by calling what? By calling my APIs, right? This API. So this is my local API, and I was able to call the model. I was able to test it. Now I can try to replace this API with my global API, so that anyone in this entire world can test my model which I have hosted. So this is called as backend deployment. I can do a front-end deployment as well. I can create a beautiful UI. I can give you an option where you can try to upload the images, and then that front end will call which one? The backend API. So basically I'm deploying my backend, by the way. Similarly, I can deploy front end. Similarly, I can deploy any n number of backend and front end, and I can call it anywhere. So this is how this entire thing is going to work. So let it deploy. So anyone who is deploying it, guys, anyone? Yeah, anyone who is deploying it? So it will take some time. As you can see that it's in a building state as of now. So it's trying to like build it. Basically, it is trying to install my requirement.txt the way I have done that in my local system, and then it will try to give you the URL. So from the URL, you will be able to hit the API, and I'm going to show you like you can hit the API and then you can do the testing. And now everyone will be able to use my URL, by the way. All of you can use my like because this is going to be my public URL, and you can just like call the URL, pass the images. You can even try to create your own UI interface, right? Own UI interface, and then like just use my API and test your model. Yeah, so new release pip available, this updated to this one. Okay, uploading build. Fine, just wait for a couple of more minutes. Okay, so still in a building phase, by the way, guys. So we have to wait for some time. Okay, so now it looks like deployment is going on. Okay, build successful. Fine. So finally, build is successful, and I believe now the entire process is going to complete in some time. Now we can easily deploy a render for getting a multiple classes regarding render. Yes. So okay, build successful. Still, it will give me the final URL. Basically, this is my final URL. So if I'm going to click it as of now 502 because still in progress, maybe in 1 or 2 minutes. So it is going to give me Sudhanshu YOLO model. Still in progress. I'm just using a free instances, so it's like a slow little bit, but yeah, if you are going to use a paid one, deployment done, they will saying, okay, great. For me, it's still in progress. So some last step is pending, and sometime it will do it. Hmm. So now Unicon app host port number this fine. Just final step. So it has given me this one. Okay, so this deployment has failed because of it is not able to deploy, guys. So it has failed because of Python multipart with pip install Python multipart track this. Frozen import leave unlocked. Okay. Common way to troubleshoot use deploy this one running unicorn port number this one. No, my deployment has failed, and I'll have to fix it. So it is telling me that Python multipart must be installed. So I can go and directly I can edit my requirement.txt in my GitHub itself. So maybe I can try to like commit the changes as per my like this one. And then I can call deploy the latest commit and then confirm. Let's see. Because this was the error. Python multipart as per the render it was missing. So I'm just trying to like deploy it. So anyone, Dave is saying that he is able to deploy. Is it like, is it working? So hopefully this time it should work. The Python multipart was missing for my render deployment. So I have just made it available here. Facing issue before going to the final stage. I thought it will go smoothly. Okay, so what is the issue that you are facing? Okay, so fine, you will be able to fix it. I'm just waiting for this build to finish. Yuri will fix everything, but I have already provided the code, right? So that code is like already a tested one. It is going to work. Okay, so now it's telling me build successful. So this time I don't have any kind of a issue, I believe, and yeah. So I think it is going to run. It's deploying, guys. So okay, so still 502. Please give a session on AWS Azure. Your any batches? I think I have given in some of the batches. Maybe not in this one. I can give that. It's very easy. So once your code is available on GitHub, right? So again, Azure provides you a multiple deployment services, and AWS provide you multiple deployment services. It's just like a same as deploying on a render, basically. But yeah, so you need like a account either way. Okay, still it is searching for the port. Just wait for some time. Yeah, your service is live. Then still it is telling me in progress. Okay, Ubicon is running, waiting for a location startup application. Okay, so now it's live, guys. And as you can see, that this is the live URL, right? So tumor medi on render.com. The Anshu YOLO 8 model for tumor is live. So my model is live. Now I can use this URL the way I was using my local URL to do the prediction. So I'll go over here and I'll just try to replace this local URL, right? And I know that there is a predict method. So this is not my local URL, guys. Now let me ping you this URL, and even you can use my URL, and even you will be able to hit my model anytime you want, right? So that's the beauty of a deployment, and I believe we all are able to do the deployment now. So let me ping you my URL. Yeah. So this is my URL, by the way, which will be available even in your resources, even after this end of the class. And let me run this one and let's see. So whether we are able to do a prediction or not. Okay. So I have to go into this folder. Let me open up a new command prompt and API testing, right? So dir, do we have API testing here? Yeah, we have API testing here. So Python API testing.py. And if you will go and check your render, right? 404 method not allowed, 404 not found. So it is telling me that it is not able to find out the predict, it seems. 405, 404 not found. It's taking a lot of time for inferencing. Cancel, close everything. Now go and check 404. Oh. Still, I'm waiting for my result. I believe someone else is trying to hit my APIs. Okay, 404. So predict and yeah, my service is still live. I can hit this URL. Okay, 200. Okay, see. And now if I'll go and check my this one, yes, I'm able to get a prediction, right? I'm able to get the prediction, a similar kind of a prediction that I was able to get it from my local system. So exact similar kind of prediction or inferencing, I'm able to get it even from here. Now I can try to store this entire information into a databases, or maybe I can try to pass on this entire things to something else. Means depends upon my business need. I can do like any kind of a configuration that I want. So is it making sense, guys? Now our API is live and anyone and everyone will be able to test it. If you would like to test it, maybe you can try to use my URL. And yeah, so till production, we are able to bring each and everything. Now, similarly, Render is a free platform and easy to use. If you have AWS account, if you have a Azure account, if you have a GCP account, so on AWS, you can try to take a one single EC2 instances. Similar manner, so you will be able to deploy each and everything. So the way we are running into a local system, if I have a EC2 system, so with a minimal configuration, I can try to run that API and I can share that API with anyone. So this is my API endpoint, right? This is my API endpoint and it's a complete open API that I've created so that anyone can hit my model and anyone will be able to get the prediction the way I'm able to get the prediction. So successfully, guys, we are able to create our YOLO model. First of all, we are able to even test it, and YOLO model from the scratch we are able to create. Now we are successfully able to test those models, the model that we have already created. Now after testing that particular model, so now successfully we are able to deploy that model on a cloud for a inferencing. Now, so once my entire things is available on this render.com, right? So once this entire thing is available on render.com, so they provide you a feature for a scaling. So let's suppose if I would like to make my inferencing fast. So I have to go with this plan. Basically, I have to go with the paid plan, even for a scaling option. So in Azure, AWS and EC2, you need a paid account, by the way, right? So basically you all are able to access our Euron services. So we have an entire server on an auto scale mode. We have configured it in that particular manner so that whenever traffic will increase, it will be able to spin more number of machines, and whenever traffic will decrease, it will be able to lower the number of the machines. So we are able to even save the cost. And again, so in case of a high traffic, we are even able to serve to everyone and without any kind of a disruption, without any kind of a interruption. So that concept is coming from the scaling basically. Then there is a concept of persistent disk. There is a concept of one-off job. So there are so many different zero downtime concept, right? So again, like auto scaling, and then there will be a reserve instances we are going to keep. So there are multiple things, and everything you will be able to do it just with the help of clicks, right? Just with the help of clicks. Even if I have to configure the job, even if I have to lease out the some disk, each and everything is available even on render.com, and it's just available with the help of clicks. You will be able to do a production grade system. You will be able to create with no time, by the way. But yeah, you have to maybe go for the payment for that. Now here you can try to come and then you can try to check all the log trails. So what has happened with your system, who is trying to hit, when your system has failed, all of these log, you will be able to check it, and then you can try to apply a custom over here, right? All logs, and even like an application log, you will be able to track it. Now, even over here, so you will be able to see the matrices. So you will be able to see like a network matrices, means a traffic that you are getting on your APIs. And then here you will be able to get even a application matrices, that how much like a memory consumption is there, how many CPU consumption is there. And accordingly, you can try to plan your entire server, right? That, okay, fine. So my consumption is going high. So obviously I have to increase my server. Basically, I have to increase my CPU, GPU, or memory, or maybe a disk. I have to increase accordingly. Now, all of these things are available on every platform, not just on Render. So whoever is providing you a hosting services, everywhere it's available. It's everywhere it's available to you. But yeah, you have to go for the payment. Otherwise, they're not going to allow you to access all of these services, by the way. So this is all about this project, guys. Hope all of you are feeling happy. Now, I would like to show you a small project, which is a part of your course, basically. So this one. I've already shown this project in my this same kind of a project in my generative AI class. But yeah, so this project is not going to take much time. What I'm going to do is I'm going to take a help of LLM. Basically, I'm going to take a help of Euron, because Euron provides you a GPT based model, and then we are going to see like a real-time sentiment, means any sentence you are going to pass, and then it is going to give you that whether this sentiment of that sentence is like a negative, positive, or whatever, right? Whatever political, whatever sentiment that you will be looking for. So you will be able to get that sentiment. Now, so previously we used to build a model from the scratch, but now we don't have to build it, because for this kind of a job, for this kind of a task, GPTs or LLMs are more than enough. So you don't have to go and you don't have to, do the things again and again and again, basically, right? Again and again. So this project is done image classification for a healthcare. So basically we have applied image detection, which is above the classification. So we are able to do that. First project, we have already done that. And again, till deployment, we are able to do it. Last project, I believe we have done that. This one I'm going to show you now. It's a very, very small one. And then this one I will be showing you tomorrow. And there are a couple of more topics which was left. So this particular part majorly, right? Otherwise, ONXX, fast API, cloud deployment, all these things we are able to sort it out. And tomorrow when I'm going to create the project, so I'll try to show you a Azure AWS kind of a deployment. So at least AWS deployment I'm going to show you. And those who will be having an AWS account, you can do a deployment along with me. So today I have shown you Render, but yeah, I'm going to show you Azure and AWS deployment as well. It's not very difficult, and we all will be able to do it. The only thing is you have to have an account. That's it. You just need an account. Now here, a real-time sentiment analysis. It's a very small project. So let's go ahead and let's try to create this small project quickly. And let's even go for the deployment if time allows. So here, I'm going to open up my VS Code, and I'm going to create my folder. Sentiment project. Yeah. Sentiment project. And here, so I just have to go and create a couple of files. So one is a app.py file I'm going to create. App.py file I'm going to create. And the another file is requirement, requirements.txt file I'm going to create. So inside the requirement.txt file, I'm going to keep a streamlint and request. So streamlint for the UI, I'm going to show you with respect to UI. And inside app.py file, so like I said, I will be using a Euron APIs. Yeah, I will be using the Euron APIs, and with the help of Euron APIs, I will be doing everything. Means whatever traffic will come, whatever we are going to pass from the UI interface, from like a app.py streamlit UI interface. So it will try to pass those data to a Euron, and eventually Euron is providing you LLM models, not just one, two, but a multiple. So Euron is going to understand that, and then it is going to give you a response that, okay, it's a positive, negative, political, or whatever it is based on the prompting, basically, right? So nowadays, this is the best way to do a sentiment analysis for any kind of a comment, feedback, whatever is available over the entire internet. To do that, there is a very basic core which I am going to pick, and it's not a big one. So here, I just have to provide my Euron API key. So streamlit I'm trying to call, request I'm trying to call, and now Euron API key. So just go ahead and try to copy the Euron API key, by the way. So from authenticate, I'm going to copy the Euron API key. And I have already shown this project multiple times, so I don't think that's a big deal. It's a very, very small project. Okay. So Euron API key, and this is the chat completion URL, which you will be able to get from a Euron itself, right? So nothing I'm trying to do it from anywhere extra. Now get sentiment from a Euron. So this is the prompt, this is the like a method that we have, which will try to take text, and then what is a prompt that we are trying to pass to my Euron? I'm saying that analyze the sentiment of the following text. So whatever text that you are going to pass, which will come from a streamlint app, streamlint like an interface, and then analyze the sentiment text, following text, and return one of the positive, negative, or neutral. Maybe I can try to mention over here that positive, negative, neutral, right? Neutral, maybe political, or maybe like a racism based, right? Whatever, like whatever I want, I can try to give a label over here. So automatically it's a LLM. So LLM is like it's a language model. So obviously it understands language more than any other model that you are going to train. So it is going to give you finally a response. GPT 4.1 Nano, I'm using it. You can try to use any other model as well. Even you can try to use a Gemini Flash for a real time, so that it will be able to go to internet, search something for a real time, and then it is going to tell you the sentiment. And then it is going to give me the response. Simple. This is the streamlint app, a simple app. So where you can try to pass your own text, right? You can try to pass your own text, and then it is going to call get sentiment from Euron, the above function, right? Above function it is going to call, and whatever result we are able to get it, we are going to show it. That's it. So this is a very small, plain, simple application, guys, we are going to create. So let me run this application, by the way. So here is a streamlint app. So streamlit. I believe streamlint is available in my this environment, local environment. So streamlint run app.py and stream stream streamlit. Okay. So now my app is up and running. Yeah, my app is up and running, and enter your text. So maybe I am not feeling good. Yeah. Analyze sentiment. So sentiment is negative, by the way, right? I'm not feeling good. Okay. So this is a wonderful day. So it's a positive. So it's a very simple one. Generally, what we used to do before is that we used to take our data, then we try to train the model. Maybe it's a machine learning classification model or deep learning classification model, or maybe a transformer based model, BERT, something like that. But the biggest model, the biggest power, the biggest asset that is available to me now is a LLM for this kind of a task. And nothing can understand a language better than LLMs, right? Better than LLMs. So this is how we can try to build a sentiment analysis. Now, if I have to host it, if I have to deploy it, it's again very simple. So let me show you a quick deployment. It's not going to be a big deal at all. So where is my render? Yeah. So what I will do is, maybe to deploy it, I can go ahead and I can try to create a new repository, right? And then I can try to click new. I can try to click basically Senti, and let's create the repository so that I will be able to push my simple code. So repository has been created over here. Now, once repository is done, and I have already tested my app locally. So let's terminate this part, CLS, and just call get init. So get init initialized, then get add, and then dot. So add everything, whatever is available inside this repository, add it, and then commit. So just commit this one, committed to file, go to the branch main, and this is my branch. This is my origin, by the way. Added the origin and then push the code. So here, push the code. Okay, so now successfully it is able to push the code. Now let me refresh this one, and here I must have like a code available. So app.py is available, requirement.txt is available, which is eventually required for my render. So requirement.txt is available and app.py is already available over here. Now if I have to deploy it, so even URI API key I have hard coded over here, which I should not do, by the way, because whenever you are going to deploy it, system and platform is going to give you a placeholder to like place your environments. So in ideal situation, I should not do that, by the way. Yeah, in ideal situation, I should not do that. I was not supposed to do it. I'll show you how to give your environment file, or maybe how to give your environment variable, like an API key kind of a things. So that you should not like do it in this way. Maybe you can just like write a URI API key as a placeholder. That's it. And everything will be done automatically. Yeah, everything will be done automatically. So here, is it fine, guys? Making sense? Yeah. So maybe I can wait for a couple of minutes, and let me ping you this piece of the code. By the way, it's a very simple one. Control C, and then in your like a chat box, you have a code now. Inside the requirement.txt, we have these two things. So this time we are going to even deploy a UI. So directly I will be able to access like a UI file, by the way. Okay. So here, basically once you will be inside the render, right? So again, do same thing, add new, click on web service. And this is the like a repository, Senti repository I have created just now. It is going to fetch that repository, and then you have to do like a couple of configuration over here. So name wise, it's completely fine. Let's suppose I'm giving Senti itself. I don't want to change the name over here, right? I don't want to change the name. So environment is fine. Branch is fine. A main branch. Root directory is fine. It's a root directory. Build command is pip install -r requirement.txt. So that is also fine. The start command you have to give. The way you try to give a start command in your local. So streamlint run app.py. So whatever Python file that you have to run, so you give it. And along with that, you have to give a server port number, a server enable cross is equals to false. So cross connection, cross is equal to false, you have to give. So this is something that you have to give while deploying on a render. So this is the only thing you have to take care of. Apart from that, so everything is fine. And if it is going to give me some error, I'll try to fix it. Fine. So here, just select a free in this particular place. And then, right? So, and then how you can provide environment variable. So here you can provide the environment variable. So whatever was the name of my variable, URI API key, although I have hard coded it, but yeah. So let's suppose if I'm not hard coding it, in that case, value. So value you can try to copy and you can try to keep it. So this is how we always try to keep all the secrets in an environment file. And or maybe I can try to call add from a dot environment, but I don't have a dot environment as of now, right? I don't have a dot environment as of now. So fine, I'll just go in this way and then click on deploy. So now this entire service, if nothing is going to break, so the entire service is going to be deployed. So again, this is the small project. If you would like to go ahead with the like a manual training or like a custom training, you can go ahead with a custom training. But for the sentiment kind of like a things, I don't think that you will be able to get enough data. Yeah, data is available on multiple repository, but I don't think that it's a wise approach to do this. So now it's like trying to do a deployment. I believe within a couple of minutes, I will be able to do a deployment. Yes, so uploaded in this one, comprehension, fine. Build is successful now. Okay, so my API is live as you can see. And if I'm going to click on this URL, so now I'm able to see my Streamlit app on render, right? Streamlit app on render. And then I can try to mention that I am like, I am not feeling good. And obviously it is able to like, it will be able to do the sentiment negative, right? So it is able to do a sentiment analysis. So this is how easy it is, guys. And especially with respect to the LLMs, it is like a very much easy. If you are not using the LLM approach, which I don't think that like you should like not use it, then maybe you can try to create your own custom model. And now we know that how to host our model, as we have hosted a YOLO model, right? On a render, and we are able to do the inferencing. So now we know that how to host the model and then how we do the inferencing. So with that, we are able to complete a lot of things today. Now, tomorrow I'll be talking about a time series analysis. So I'll be talking about this project with respect to LSTM and other approach as well, that how we can try to do a time series forecasting in a detailed way. We'll try to deploy this model after creating a model on some of the AWS and Azure platform, right? Plus, I'll try to show you even inferencing with respect to vision transformers and image segmentation. So like, again, it's not a big deal. It's like a extension of the detection that we have done. But yeah, so I'm going to show you these things. Plus, if there will be some small topic which will be pending, which I don't think that we have, because most of the topic we are able to cover it from all the segments. We'll be talking about it, and then tomorrow we are going to conclude your class. And if someone will come and say in our group that this topic is pending, that topic is pending, then maybe we can try to take or conduct some sort of extra classes in a weekdays, right? So with that, guys, thank you so much. Take care, everyone, and see you again in my tomorrow's class. So where we are going to see again a project. With that, thank you so much, everyone. Take care.